Hello everyone. This is our second lecture for Chapter 11, Two Related Samples T-Statistic. In this video, we will continue with hypothesis testing steps 3 and 4, and we will discuss effect size, advantages and disadvantages of related samples t-test, and its assumptions. Hopefully, you recognize these formulas' structure. Variance and sum of squares are calculated in the same way. All we are doing here is substituting X, raw scores, for D, difference scores. These formulas should all be very familiar to you by now. Step 3 is to calculate a related samples t-statistic. Here is the formula for related samples. This should also look somewhat familiar as it resembles the one sample t-statistic formula. The related samples t-statistic formula is structured as follows. Sample mean of difference scores minus hypothesized population mean of difference scores divided by estimated standard error. Based on the null hypothesis, the hypothesized population mean of difference scores is always equal to 0. So this is always equal to 0. So we can simplify the numerator and we just have the sample mean of difference scores divided by estimated standard error. The numerator measures the actual difference between sample mean of difference scores MD and the population mean of difference scores μD. The denominator measures the expected difference between sample mean of difference scores and population mean of difference scores if the null is true. Estimated standard error of difference scores gives us this expected difference. For related samples t-statistic formula, estimated standard error is calculated as the square root of the sample variance of the difference scores divided by sample size n, where n is the number of pairs, or sample standard deviation of difference scores divided by the square root of n. Step 4, to make the decision, right? To make a decision, we compare the obtained or calculated t-statistic to the t-critical value. We reject the null hypothesis if the obtained value exceeds the critical value. If we reject the null hypothesis, we must provide a measure of effect size. Effect size for related samples t is measured in the same way that we measured effect size for one sample t in Chapter 9. Specifically, you can calculate an estimated Cohen's d, or you can calculate r squared to get the percentage of variability in a dependent variable explained by the independent variable or by the treatment effect. When estimated Cohen's d is used with related samples t-tests, we place the mean of the difference scores in the numerator and the sample standard deviation of the difference scores in the denominator. Another measure of effect size is the proportion of variance or variability in a dependent variable that is explained by the independent variable or the treatment. Percentage of variability is calculated using the same formula for one sample and independent samples t-test. Effect size can also be calculated using confidence intervals. Same as we did for one sample t-test in Chapter 9, we find the interval estimate reported as a confidence interval and stated within a given level of confidence, which is the likelihood that an interval contains an unknown population mean. Using mean of different scores, we calculate the confidence interval by adding and subtracting a margin of error, which is obtained by multiplying t-critical value and estimated standard error. The advantages of related samples design is that it requires fewer participants, especially if we're observing pre-post. We are able to study participant changes over time. Related samples designs reduce or eliminate individual differences since we are using the same participants, which leads to substantially less variability in scores. The disadvantages of related samples design are as follows. There might be factors other than the treatment that causes participants' scores to change during the time between measurements. Participation in the first treatment could influence scores in the second treatment, what we call order effects. However, counterbalancing is a way to control time-related or order effects. One last slide for related samples t-tests. The assumptions that must be met in order for us to conduct a related samples hypothesis test are: 1. Independence of observations within each treatment condition, and normal population distribution of difference scores. I will post a video to demonstrate how to conduct a related samples hypothesis test.